what type of channels do we have on the nerve or neuron, and why are they important? So, for example, if this one is right, and this one is postsynaptic neuron, okay, you gotta understand that
Зарина, иди выключи, пожалуйста, громкий звук, а то я не могу.
by doing that, you're ensuring, or one of the reasons why inside is negative, also you're restoring the balances after the depolarization and repolarization. Sodium potassium pump can also restore the balance as well. So we discuss about what happens in the axon hillock. There were a lot of sodium voltage gated sensitive channels there. We discussed that along the axon you have leak channels. We discussed that on the synaptic terminal, or at the end of the axon, axonal terminal, you have calcium voltage gated channel. So if you recall and take a look at what is happening in here, or maybe I should say in here, right? Very similar to the neuromuscular junction that we discussed. In other words, inside of the vesicles were kind of like a bubble-shaped structure. You had different type of neurotransmitters. Neurotransmitters eventually they are made from the DNA, giving the rise to the messenger RNA and the protein, and the proteins are placed into these vesicles, and these vesicles are now shifted and brought to the axonal terminal. But you need the action potential to open up the calcium channel. So eventually, action potential that we discussed, it generates right around here, and it comes and opens up the calcium channel because it's voltage gated sensitive. When there is enough voltage, calcium goes in, and as a result of that, that causes the fusion of and releasing of the neurotransmitter via exocytosis. All right. Now there are different neurotransmitters in here. It could be acetylcholine, it could be other GABA, it could be serotonin, it could be glycine, it could be glutamate. So we had a whole bunch of different kinds of them, and it is on the post synaptic neuron. Now remember, this area is called synaptic cleft. The communication between the two neurons is called synapses, and we need to kind of like talk about a little bit about these type of neurotransmitters. So make sure at least what are the categories of the neurotransmitter. In other words, we discuss whether they are excitatory or inhibitory, IPSP and EPSP, excitatory post-synaptic potential, were all those neurotransmitters that causes the action potential to occur more likely. So on the postsynaptic potential, if this is the postsynaptic potential, right, you had a ligand-gated channel that normally are closed, but as soon as the let's say the particular neurotransmitter binds to it, now a little bit later on, I'm going to show you in here, this is supposed to be the same thing. As long as this neurotransmitter binded in here, it opens up the ion channels. Now, what kind of the ion channel it is depends on the type of neurotransmitter. So let's assume on this one, let's say it's a glutamate, and it's a excitatory signal. Then what happens again? Sodium or calcium that have higher concentration outside, and they can go in. And entry of this sodium going in really depends on many different factors. But if in here we have negative 70 millivolts to start off with, this was the resting potential. Now, obviously, it becomes less negative. Less negative meaning what? Meaning like few of these sodium maybe going in, now is negative 65. More is coming in, now is negative 60. So you could see it's becoming less negative. All right. Now, eventually, these neurotransmitters are being broken down by their specific type of enzymes. For example, acetylcholine esterase that can break down the acetylcholine, or there are other enzymes that can break down other neurotransmitters. But if you do this before the thresholds is reached, all right, action potential is not going to occur, right? So let's say that in here you have a negative 70 millivolts, that's your resting potential, all right? But because the sodium came in, this goes in towards the negative 55. But let's say at this point in time, we say it's excitatory because action potential is more likely to happen because the distance to get in here to cause the action potential is not that much, all right? But if you, let's say, you have way too many enzymes and not that many this type of neurotransmitter, whatever that is, and you start digesting them or blocking them or whatever the case might be, then this goes back to the resting potential. But if there is enough sodium is coming in, once you reach the negative 55, then obviously, these voltage gated sensitive sodium channels are opening, and that causing the action potential. In other words, you could reach up here, and once you do, then boom, that causes the other channel to open too. So this is kind of like a positive feedback, because the change is voltage is becoming less negative, but instead of counteracting it and bringing it back, in this case, might cause more and more sodium ion to go in because there's more channels available, and so on the axon hillock. And so that would be kind of like a positive feedback as well. All right. So make sure you know the components that the communication are taking place, and understand, what is happening in there. I think that was one of the things that we discussed. All right. Obviously, you need to know the events of the action potential as well. The events of action potential. Now, before I go on to the events, I want to open up a parenthesis and tell you that there are multiple questions. So you do not know, and I don't know which version you're going to get, but everything kind of like shuffles up, and the system randomly picked some of the questions from the test bank that I created it. Many of these test banks, are related to the chapters that we discuss, and obviously, so at times you may not. I cannot ask everybody everything. That's why, uh, they are randomly picked for the integrity of the exam. So don't be disappointed if I didn't ask, for example, a specific type of questions that I go over with, or you studied for. Some students have a tendency to get upset. Say, "Oh, how come you didn't ask me that?" Well, actually, I might have, but the computer randomly picks those questions, so it may not pick the ones that you studied because they don't know what you studied. You have to study everything, so that way you are safe. However, if you come across of those type of questions that you didn't study, or you studied and they didn't ask you, all right, that's kind of like it is what it is, and it happens at times. So the process of action potential, if you recall, you're starting with the resting potential. You reach the threshold, which was negative 55 millivolts. In order to get there, if you have a negative 70 millivolts, you only need positive 15 millivolts to get there, to get to the negative 55. After that, basically, the sodium channels on the axon hillock is going to open up, and again, that causes the action potential. Action potential is all or none. What that means is either fire or it doesn't. Okay, if it's below this threshold, it doesn't fire; it dies off. Okay, now if it does reach, then you go in towards the depolarization phase, which was right over here, and that would be determined and basically depicting that the permeability for sodium ions through the membrane increase, and the more sodium is going inside through the respective mostly voltage gated channels, and as a result of that, you're reaching the peak, in this case positive 35, which was right around here, positive 30 to 35 millivolts. And then we're going over the repolarization. During this phase, obviously, we discuss about the refractory period, which temporarily, once the sodium channels are closing after this peak, all right, because there is no more driving force for the sodium to go in. Now it's causing the potassium channel permeability to increase.
Hi, Professor.
I was middle of something, but go ahead. Go ahead.
Can you turn on the recording? No, turn on the recording to record the lecture.
I'm not going to do that. Okay? This is not a lecture. This is a review. And again, if you like to do it for yourself, that's fine. But the reason why I do not recording the lecture, because I don't want you guys to just study this. All right? And it's not really a lecture. All of these you've had before. Okay? I'd rather answer your questions, and for that reason, I really don't want it to review the content. So you guys though can participate if you like. All of these are review. So we discuss resting potential, and resting potential, again, if you get to the threshold, then it fires. Action potential is going to go. And then again, that would be the depolarization we discussed. As you coming down, maybe I could use a different color. All right, this part right over here, permeability for potassium ion increases. So more potassium going out. All right, so as the cell loses the potassium, you're going back towards the negative, which is termed as, what is it termed as? Do you guys know? Repolarization. And on the other side, we discussed that would be the sodium coming in. This is also known as influx. Influx when somebody coming in, and this was depolarization. All right, and then we had a third phase that would be the hyperpolarization. So during this event, hyperpolarization, potassium channels are too slow to close, so more potassium is leaving at this point in time. But then again, sodium potassium pump restores everything, and you're going back to the resting potential. So in a nutshell, that would be what is happening during the action potential events. All right. There were a lot of details like leak channels. Make sure you know that there are more potassium leak channels that contribute to the Y's inside of the cell was negative. So inside of the nerve was negative. This was negative 70 due to the protein channels that protein molecules that are negatively charged inside of the cell. They're too large to leave. They stay in there. So that would be one reason. Another reason was more potassium leak channel. Pretend these are the potassium leak channels. So there's a lot of them, and therefore potassium freely moved to the other side because you had higher amount of potassium inside as opposed to the outside. So if you have more leak channels, they are moving towards the outside more. And finally, we discussed about the sodium potassium pump, and the sodium potassium pump pumping 3 sodium out as opposed to bringing 2 potassium in. So if you're looking at these pumps pumping more positive ion outside. So what that means is this is the reason why inside is negatively charged. One thing about the sodium potassium pump is ATP driven. So as long as you have the ATP is constantly working, it does not stop. Common mistake, people think that the sodium potassium pump is dependent on the neurotransmitters. It's not. Okay? So make sure you understand that. All right? So that was majority of the things that are happening now. We discussed what are the ways that earlier I showed you that on the postsynaptic, this is postsynaptic neuron. And what do we do with this? Again, enzyme could come in and break this apart. As soon as the enzyme is going, the channel is going to close. When there is no enzyme or the neurotransmitter is binded to it, is open. So some ions, they could go in or out. Another one that we discussed, these neurotransmitters, they could just come apart. And once, they're not completely attached, in other words, they can attach and depart. And then again, we discussed about the role of astrocytes. Astrocytes, they can engulf them and digest them as well. So those are the 3 ways you need to know what you do with the neurotransmitter. Now, we also mentioned that the neurotransmitter, once it's broken down, they can be reuptaken back into the presynaptic neuron, and again put it into the vesicles, ready for the next action potential to come in to do the exocytosis. All right. We also need to know what happens on the here. Okay, let's assume that enough neurotransmitter came in that could cause the action potential. What about the inhibitory postsynaptic potential? Inhibitory postsynaptic potential, one of them was GABA, if you remember. All right. So if you have a GABA and the GABA is binding to the receptor and opening up this, let's say, chemical gated channel or ligand gated channel. All right. Now, instead of positive ion coming in, it could be negative ion going in. So, for example, chloride is negative. This channel could be for chloride. As chloride is coming in, inside is going to become more negative in this case, negative 70, more chloride coming in, obviously you're going towards the negative 75, negative 80, etc. So at this point in time, inside becoming more negative, in other words, this is a hyperpolarization. During hyperpolarization, action potential is less likely to happen. All right, so we discussed about the EPSP and IPSP. Are there any question about EPSP and IPSP? Action potential more likely to happen or action potential is less likely to happen? Any question on that?
I have a question.
Sure, go ahead.
When you were asking about what kind of summation and if an action potential will occur,
Time out. I haven't talked about the temporal summation in our review. Let's hold on to your question for a second. Up to this point, EPSP and IPSP, anybody has questions on them? Okay, I didn't mean to cut you off, except that I intended to go over the different type of summation. Let me go over the summation and then please feel free to ask questions afterwards, okay? All right? Did you get offended when I cut you off?
No, that's okay. Then
Okay.
can I just ask about if an action potential will occur or not? For the inside, for the millivolts, does it have to be at least positive 15 in order for an action potential to occur?
Yes. In order action potential to occur, you need at least to get to the negative 55 millivolts. All right? If you can achieve that, the axon Hillock is right here, and there are plenty of voltage gated channels here, but they're normally closed. They take at least positive 15. If you apply a positive 15 in here, then it can open these up. All right, once they're open, then the sodium can go in and again causes the action potential or depolarization on this side, which again, due to the temporarily not functioning them due to the refractory period that we discussed, the action potential will go only one way. All right, but let's go ahead and take a look at the summation. Did I answer your question?
Yeah, that was my question. Thank you.
Okay, so in other words, the specification for EPSP or IPSP is not whether the action potential is going to occur or not. It's stating action potential is more likely to happen. And when inside becoming more positive or less negative, all right, what that means is action potential is more likely to happen. So most likely, whatever that signal was excitatory. In this case, is an IPSP. Action potential is less likely to happen. In this case, because of the chloride negative is going in, and as a result of that, you have more negativity inside. So this signal is IPSP. All right. Now, different neurons on a daily life can obviously influence and give us signals that are positive or negative. Let's say, right now you're thinking about having food, all right, and just leaving this meeting and going into the refrigerator, all right, so the neurons involved in your appetite center are excitatory, and they excite those neurons, and this signal goes into the appetite center, hypothalamus, etc., and the thirst center. So now those are excitatory. The neurons that are involving in perhaps comprehension, learning, and vision, and hearing, and all that, after a while you may not even hear me, all right? You're hearing me, but you're not actually listening. You're thinking about something else, and so on. So those neurons are actually fighting and inhibiting that particular area. Instead, your appetite center or your thirst center in the brain get excited. So you could see how you can turn off or on some things depending on what you're trying to do. All right. But let's go to the summation. And maybe you guys can help me out. There were two kinds of summation. Do you guys remember the two kinds?
And
Temporal and spatial.
Good. Temporal summation and a spatial summation. Good job. All right. So what was a temporal summation? Now, tempo comes from the word time. Does that ring a bell? What is the temporal summation means?
more action potentials will occur in shorter time.
Rapid impulses.
Rapid impulses. So in other words, if you keep zapping very closely, keep zapping, you have one electrode inside of the neuron and you zapping it with, let's say, positive 10. Positive 10 by itself is not going to cause the action potential to fire in this case, and there is nothing to sum. But if another positive 10 signal coming right after that, all right, these signals that are coming one after the other, in other words, there is a rapid fire action, these are called the temporal summation. So basically you're adding up, all right? Whether the action potential is gonna occur or not, again, that depends. You could add up positive one, another positive one, another positive one, another positive one, and then that's it. You don't add anymore. In this case, action potential is not gonna occur, but summation is still taking place, all right? What was the spatial summation then? Do you guys remember? Go ahead, if you know.
Many different signals coming in at the same time.
Correct. So now you have a different electrode. For example, you put in different electrode into the neuron, but you're zapping it all at the same time. Now this electrode, for example, could be applying positive 5 millivolts. This one maybe negative 5 millivolts. And this one, the idea is coming all at the same time. And this one is, let's say, positive 10 millivolts. Do you think the signal, when they're all coming at the same time, is this a spatial summation? Yes or no? They're all, you're zapping it all at the same time. Yes or no?
Yes, it is.
Yes, it is the spatial summation. Is the action potential can fire in this case?
It's not necessary.
Not necessarily. Yes or no? Does the action potential fire?
No.
No. Why not? Because positive 5 and negative 5, they cancel one another. And I only have positive 10 remaining in here. Positive 10 is not going to cause the action potential to fire in this case. So again, all these signals are adding up. All right? Where in the soma, which is the cell body of the cell, that is right around here. So you had the nucleus, and the area around it was called soma in your anatomy, or also known as a cell body. Soma or cell body. That was the part of the anatomy that you learned. Okay, so in the soma or the cell body, all this summation is taking place, and you should have a good idea about the temporal summation and also a spatial summation and what it is. Now, we also mentioned that the neuron, some neurons, they have myelinated sheaths. These were the Schwann cells. Myelinated sheaths speed up the conduction and the action potential jump from one node to another. These are called what? Nodes of?
Ranvier.
Ranvier, good job. So those sodium and potassium voltage gated channels happens to be on these areas right here. So that's why they don't need to go through so many channels underneath here of the Schwann cells. So these are myelinated sheaths. So this was referred to as saltatory conduction, if you recall, and therefore you could get there much quicker. A lot of our motor neurons are like that. Our motor neurons control the muscles, and these nodes of Ranvier exist, and myelination is existing. And we discussed about the MS or multiple sclerosis, where these can be attacked, and as a result of that, you have neurological problem. But interestingly enough, The myelinated sheets are there. During the signals that's supposed to get there fast, think about how fast you could move your muscles, all right? They are heavily myelinated. This may not be the case in terms of the sympathetic and parasympathetic fibers, so they're not heavily myelinated, okay? So the signal is not as fast. Anyways, we discuss about the dendrites. Dendrites is where you receive the information. All right, so the information is coming in through these dendrites, obviously, and they convey the incoming message towards the cell body that we discussed. They also provide enormous amount of the surface area. They can also be involved in a graded potential. Now, graded potential is decay with distance. So, for example, let's say you receive the signal, you know, whatever the channel was open, and you receive some positive signal, but let's say it stopped in this case. And let's say this is not enough to cause the action potential. Let's say it was positive 10. You know, by the time you're reaching here where the axon hillock was, the signal is going to be even lower. So now maybe it would be, if the initial signal was a positive 10 millivolts, and we're starting at negative 70, then you get to negative 60 millivolts. But as you're going further and further and further, all right, this dies off. In other words, right here, I'm putting a measurement and finding out what would be the measurement in here. That might be negative 65 because it's not closer in it. It dies with or decays with distance. All right. At the same time, if I put it right here, maybe it would read, you know, negative 67 because it's closer to the negative 60, no, negative 65. Maybe this one would be negative 63. All right, because it's closer to the negative 60. So you could see what is happening. The distance is going to be decay. All right. Make sure. What else we discussed on the action potential? I think majority of chapter 11 we discussed. Is there any parts on chapter 11 that you're struggling with, you guys? All right. So make sure you review absolute refractory period and relative refractory period. Make sure you understand the idea. All right. The period after an initial stimulus, when a neuron is not sensitive to another stimulus, is called absolute refractory period. In other words, while the sodium channels are resetting, even if you put in a lot of voltage, they're not going to react to it. They need to reset first. So for that, we said the neurons is sensitive to another stimulus, because if you zapping it with even higher voltage, you're still not going to be able to achieve that. However, that is not the case in terms of the relative refractory period. Relative refractory period, a larger stimulus is needed, but the action potential can actually fire. So imagine that the voltage-gated potassium channel ions are remain open at this point in time, and hyperpolarization is occurring. But during that time, if you apply a lot of voltage, you could go from hyperpolarization to the threshold again, and then boom, action potential could actually be fired, but you need a higher stimulation. And that would be the idea of the relative refractory period. So we discussed what happens in the neurotransmitter. Why is it some neurotransmitter, they have two different effects? For example, acetylcholine we discussed in the muscle was a stimulatory effect, but in terms of they actually had inhibitory effect. And the reason why is because they have different receptors, all right? And in sympathetic activity, for example, acetylcholine can act as an inhibitory signal, right? So their channel is different, communicated channels are different, and that is why they have different receptors. So we discussed about the role of leak channels already, and I think for the majority, those are the things that really you should put your concentration on regarding the action potential in chapter 11. In other words, what happens before the communication, in presynaptic neuron, what happens at the junction, and what happens after that. All those events, including the summation, IPSD, EPSD, type of a neurotransmitter, etc. Now, interestingly enough, we mentioned that the axons or the neurons with the myelinated sheath, they travel faster because of the saltatory conduction. But also the diameter of the axon is important. So in other words, if the diameter is larger, let's say this is the larger diameter, they also have the Schwann cells, all right? Now this would be quicker, right? Why? Because there are a lot of voltage-gated channels. So when enough sodium goes through those voltage, it's going to open up all those in the axon hillock anyways. So that action potential is faster because they could get open quicker, all right? So that's another thing that you wanted to think about. I told you that the action potential is one way only, and it can go unidirectional. So in other words, if I zap the axon here, the action potential will go this way, all right? However, if you have a neuron and you zap it in the middle, all right, what do you think is going to happen now? Anybody that looked at the lecture, what did you guys remember? Can it go one way, or can it go both ways, or it cannot go anywhere? What do you think is going to happen?
It can go one way?
So you're saying that it could go only this way? Yes? No? Maybe?
Yes.
Okay, anybody else wanted to confirm or dispute?
I think it can go both ways, sir.
It could go both ways. Both ways correct. But why earlier I told you it could go one way as opposed to this one, it goes both ways. You're absolutely correct and good job on it. All right? But why do you think it could go both ways in this case?
The action potential has to reset.
No, that's not the reason.
Like it can't backtrack. Because we have in both way natural voltage gated channels, and they can open.
Right. Good job. So basically, what is happening is that pretend that these are the sodium voltage gated channels. So they're opening. Sodium is going in and causing depolarization and causing the nearby to get depolarized. So yes, it can go this way. But also, these positive ions all right, they can open up nearby channel that is sodium voltage gated channel as well. So it can go this way as well. Now in here, you don't have much of a neurotransmitter, so again, it dies off when it travels via the distance. But remember, right after that, the sodium voltage gated channel, they're going to become inactivated. So now the nearby channel can get activated and this one is not. So once it passed that and opened up other sodium voltage gated channels, now what is happening, sodium can come in, but now this cannot influence this one, all right? But earlier on, we started off at the soma because that's where the receiving incoming signal is coming in from the dendrites. So when you start off in here, all right, then they cannot go back this way because there are no voltage gated channels on here. The voltage gated channels are all along the axon. That's why when you communicate via the dendrites. That's the reason why. But yes, it can go both ways. Okay. Next up was chapter 13. Before I go to chapter 13, are there any questions, you guys?
Professor?
Yes.
So you're saying that when the action potential goes towards the dendrite, it dies out?
No, I did not say that. Oh, you mean which one? You mean this signal?
Yeah.
Okay, so it dies off from the point that you causing the change. So for example, let's say this was, I don't know, positive 30. All right, let's say inside is positive 30 because you applied, let's say, I don't know, let's say you apply positive 30. So inside, if it was negative 70 plus 30, that would give you what? Negative 40, right?
Yeah.
Okay, so now you only need negative 55 in order for the action potential to occur. But you applying positive 30, so inside is negative 40. The action potential is going to fire on this end, but also in here as well. But as you're going away from here, you're going over this way, and then over here, you're further up and so on. So this is going to go lower and lower and lower. In other words, it decays with distance. Does that make sense? So in other words, after a short period of time, if you measure right over here, that will not be negative 40 anymore. Okay? Delay.
Okay. Thank you.
Mm-hmm. Okay. Any other question regarding the action potential, you guys, and chapter 11? Okay. Chapter 13 was about reflexes. So make sure you know the components of the reflexes. Make sure you know the order in which they occur, and make sure you can identify what is happening with the reflexes. Now, reflexes are automatic. We discussed first is the sensory receptors, then you have the sensory neuron. Information goes to the control center. A lot of times this control center is either a spinal cord or the brain, and then exiting from there, that would be the motor neuron, and from motor neuron, you're reaching the effector, and that's the time that you are performing the particular task. Now, if you do a knee-jerk reflex that we discussed, here is your knee, for example, all right, here's your foot, and if you have a rubber mallet, for instance, and you apply on the patellis tendon, what happens? You are, you do a knee-jerk reflex, and this knee-jerk reflex is always this way. So again, if you do this later on in time, or tomorrow, or next week, or next month, and so on, you're still gonna get the same. Oh, I don't know what happened. You're still gonna get the same result, which is the knee-jerk reflex. In other words, it does not change, all right? So in other words, on the reflexes, there are a lot of automatic reflexes, you perform the same task because it goes to the same chain. In this case, again, sensory, you have proprioceptors in here. All right, these proprioceptors, we discussed, they detect the ligament stretching, degree of a stretch. Then you have the sensory neuron that are happen to be on the muscle, and then it goes into the spinal cord, goes into the quadriceps muscle via the motor neuron, and the quadriceps muscles react. And in this case, you do a knee-jerk reflex, and every time is going to be the same chain of loop. All right. So make sure you understand that. We also talk about different type of receptors based on the stimulus, based on location, based on the structural complexity, and you need to know those. So, for example, if I give you a scenario and I told you a person is eating ice cream, is cold, based on the location, what type of a receptor would this be? You cannot say it's a thermoreceptor, right? Thermoreceptor is not a location. So make sure you understand the question. Don't just jump into it, all right? Make sure you read it. So based on the location, that would be extraceptors. Extraceptors, the receptors are located towards the outside or surface of the body. Intraceptors were within the body, all right? So as your tongue feeling the coldness of the ice cream, yes, based on the stimulus type, that would be a thermoreceptor, all right? It could also be chemical receptor because you could detect the chemicals, in this case, sugar molecules and such, all right? And you could also feel the texture. So it could be a mechanoreceptors. So there are some gray part to it, but make sure you understand all of those and the criteria for that, and I think you'll be in a good shape. All right. So we also talked about different examples of each one based on the stimulus type, based on the location. Proprioceptors, they detect based on the degree of a stretch. And nociceptors was a pain. And if you did the sensory transduction lab, they talked about the capsaicin and, when the person was hit by the rock, and they talk about the pain receptors, and those are all nociceptors. Nociceptors associated with pain, all right? And based on structural complexity, we discussed that could have a free nerve ending. Many are touch receptors that have free nerve ending, and they are, considered as simple, and they don't have that connective tissues around them, so they are unencapsulated. And some of them do have connective tissues around them. If you remember, these were the free nerve endings, all right? They could be underneath our skin, but at times, again, Meissner corpuscle or Pacinian corpuscle that look like chopped onion, all right? Those were having these connective tissues around them, and that would be the encapsulated ones. They're all category of the simple receptors based on the structural complexity, and the complex receptors happen to be in the special senses, like your olfactory senses or your rods and cones in the eyes and so on. They're really special, and they just belong to the that particular sense. You cannot find it anywhere else, okay? So they're really unique, therefore those are the complex. But other than that, we discuss about the neural pool, so make sure you have some ideas about the neural pool. We discuss about the divergent, convergent, revibrating. We discuss about the parallel after process. We discuss about the serial processing, and so on. So make sure you at least know an example of one. When one incoming signal coming in, but the output are many, all right, that would be the divergent. When there are many signals are coming in, but single signal is going out, one output, many inputs, that would be the divergent. And again, whenever the signal going in back to the same loop, reverberating. And I gave you an example of each in our lecture. Make sure you review those. Remember, the examples could be different. You need to think about the concept and learning them rather than memorizing and hoping that I'm going to ask you exact same scenarios. So make sure you do not limit yourself to the examples I provided to you. All right. Other than that, that was the topic of chapter 13. Was pretty short, I thought. There is interneurons. So make sure you know the category of the neuron. We discussed sensory neuron. We discussed motor neuron and interneuron. Motor neuron information is going from CNS out, all right, to the effector. Sensory neuron taking information to the CNS, all right, and the interneuron happen to be within the CNS, whether it's within the spinal cord or within the brain. It just transmits the signal from one area of CNS to another area of the CNS. So that's the idea about that. All right. So anything that has something to do with sense of position and movement of our joints is gotta be proprioceptors. All right. So, for example, your eyes is closed right now. Go ahead and do this if you like. Close your eyes and raise your finger and touch your finger, touch your nose. All right. Were you able to do that? All right. Well, how do you know where your nose is? Okay. Again, these are all proprioceptors. All right. The position and movement of our joints allowing you to understand and know what degree of the stretch is taking place for muscles, and as a result of that, these sensations create awareness of our body. All right, so that is the case. Now, if I tell you, you stepped on a nail and it was awful and it was painful and so on, and that would be an example of the nociceptors because it's associated with pain. All right, so make sure again you understand the idea. The spinal reflexes, we discussed that, and you should have a good idea about the reflexes. Let's see. Certain reflexes, we said they are extrinsic and intrinsic. Inborn or intrinsic reflexes is the ones that we do not need to have practices. All right, it's involuntarily. All right, let's say accidentally you touch a pot that was hot, you let go right away. Did you really need to have experience doing that before? No, that happened automatically. All right, you didn't go and experience by burning your fingers to let go of the pot. So you learn that. Certain reflexes, however, we achieve and by experience by doing them over and over again. A lot of athletes are quite familiar with it. Okay, martial arts people, how to dodge people, kicks and things like that. That comes in with the practices. All right, the reflexes are super fast. Those are voluntary reflexes. Those are we have control over them. All right. So as far as the inborn, you don't need any practice doing that. Okay. Now, if I give you fill in the blank questions, you need to type things up. All right. And again, there could be few of them. Just because I'm giving you one way, it doesn't mean that, it's always going to be that way. There are sometimes fill in the blanks. And again, there could be choices that you could pick, or you need to write things down. Something simple, not too complicated, anything like that, but you got to make sure that you have a correct spelling on it. All right. So if I told you, for example, somebody touch your skin, this is an example of based on stimulus type. Perhaps you should write, mechanoreceptors, for instance, right? So you got to know. Or the neurotransmitter in muscle contraction is, you should write down acetylcholine. Okay? All right. So chapter 14, which you guys going to have another quiz today at 1 o'clock, is related to the sympathetic and parasympathetic activities. All right. So you really need to get this down, different aspects of it as well. Now, listen, you got to know the difference between somatic nervous system and autonomic nervous system. Somatic nervous system, we have control. Autonomic nervous system is kind of like automatic. This is where the motor division had the sympathetic and parasympathetic activity. You're not in control. Yes, at times you could be nervous and all those things happen, all right? But again, category of autonomic nervous system. It's not like you could tell your heart, okay, slow down, all right, I'm not scared anymore if something is scary is coming at you. At that time, your heart is going to go up, all right? So make sure you understand about the autonomic nervous system and their effects, okay? That's all I could tell you. They usually have a counter effect. So when one is doing one thing, the other one is going to undo the other. So for example, if heart rate goes up during the sympathetic system, during the parasympathetic is opposite. They don't have the same reactions. Again, you got to know about the preganglionic and postganglionic neuron. In preganglionic neuron, whether you have a short preganglionic or long postganglionic, all right, make sure you know where the ganglion is located. Is it close to the cell body or is it closer to the effector? What type of neurotransmitters are involved? Remember that in association or communication between preganglionic and postganglionic, it was always acetylcholine, but in terms of the postganglionic neuron, it was either norepinephrine or acetylcholine, depends on whether you had the sympathetic and parasympathetic. So make sure you know the type of a neurotransmitter that they are involved and what do they do, all right? And also the effect. A lot of things happens for a reason. We discussed what happens during the parasympathetic division. Those were the D-related activities, and what was involved in the sympathetic activities, which was E-related activities. E for excitement, E for embarrassment, E for exercise, E for emergencies, and so on. So we mentioned during sympathetic activity, you become more alert, your pupil dilates, all right, your heart rate goes up, your respiratory rate goes up, the blood is going to go towards the muscles, so there's going to be less of those available for digestion. You can't digest. If you're camping and you see a grizzly bear coming in at you, your sympathetic activity is going to kick in. You become more alert, your pupil dilates because you want to know what to do. Where is the road nearby that you could exit, whether you should go on top of the tree, whether you should get the log and defend yourself, whether you should run, and so on. So all of those things happening very, very quickly during the sympathetic activity. All right. But let's just say the bear changed its course and moved away from your area and left. Now you could relax. Now parasympathetic division kicks in. Now your digestion is occurring. So basically, sympathetic activities, it primes the body for energy-consuming activity versus parasympathetic activity primes the body for energy-conserving activities. Keep in mind that during the ejaculation and so on, we discussed about two phenomena. One was during the erection process, you need to be relaxed, and during the excitement and ejaculation process and so on, that would be the sympathetic activity. A lot of the students have a tendency to get this wrong as well. Urinary input or urinary output and urinary bladder. Again, you need to be relaxed in order to have urinary output, all right? And when you're nervous and so on, you may have a hard time relieving yourselves, all right? So that was sympathetic, parasympathetic activities. There is a lot of hormones that comes into a place as well. And we mentioned that one of the ways in which these control of the temperature, endocrine activity and hormone, the thirst, and the boss, and how all these sympathetic activities and parasympathetic are being controlled and so on happened to be hypothalamus. All right. So hypothalamus is important, and again, we have ideas about that because when you remove the hypothalamus from individual, all those problem comes in, and that is the big problem. All right. So skeletal muscles, they're not on their autonomic nervous system. They are directly controlled by the somatic nervous system. All right. So we have control over them. In terms of let's see. Now, in terms of the sympathetic activity goes, mentioned that they release the neuroepinephrine. And what is it the neuroepinephrine does? It dilates the bronchiole, all right? And as bronchiole dilates, what happens is you can, the efficiency of the gas exchange is going to be increased. In other words, you're increasing the blood flow, all right? When something, the diameter is increasing. So here we go, this is the diameter is increasing. Now there is going to be more airflow in here, obviously. And more airflow, more gas exchange. Again, you want more oxygen to send into your tissues, including your muscles. Because
Bottom.
Yes, go ahead. Huh?
Bottom.
I'm sorry, I didn't get your question. What is it? Did you guys hear something? I don't know.
Yeah, I heard it, but just keep going. I don't think it was anything.
Okay, all right. Vasodilation is important, but you gotta know what is it that you're doing, all right? Vasoconstriction is important. You gotta know what is it doing and where is it vasodilating, where is it that vasoconstricting. Same thing with the bronchiodilation and bronchoconstriction. Now, when you relax, you don't need to deeply and breathe so much oxygen and so on, because again, you don't need to consume so much energy. All right. Now, erection, however, erection of the penis or clitoris and the penis, obviously, the part of the reproductive system. As you know, during the sexual intercourse or right before that, they get engorged with blood. Well, obviously, what is have to happen is vasodilation has to happen. All right, as the blood flows to the penis, obviously it engorged with the blood, and you get the erection. So at this point in time, obviously vasodilation is under the parasympathetic activity. I don't know if I mentioned this, but parasympathetic activity is kind of like it starts with pain, with P. That means point. You could think about, the penis. It starts with P and points upwards, kind of like a erection. So that's giving you a clue, at least one way you could associate things with one another. All right. As far as the sympathetic activity goes, there is a lot of regulation of blood vessel diameter, cardiac rate, regulation of the respiratory rate, regulation of the pupil size. All of those are the function of the sympathetic activity. All right. For a reason, because you need to be more alert. Remember that. All right. So sympathetic activity increases the blood glucose intake. In other words, you need more energy in order to do that. Whatever it is, you need to burn the energy, so that way you can get your muscle going. And we discussed this already in the ATP. You need to do less gastrointestinal GI peristalsis. All right. You need to increase the heart rate, and also the increase in the blood pressure. All of that is important because you wanted to transfer more blood to the muscles in this case. So you could run faster, you could metabolize glucose faster, you could get the energy faster, and you could defend or flee. Remember, sympathetic activity is also known as fight or flight. Parasympathetic activity obviously is a little bit different. All right, it's kind of like cutting it. All right, so this also your lens accommodation, your close vision, those are under the parasympathetic activity, because you don't need to see far. You don't need to see more light coming in and so on. So close vision and accommodation, which is, changing the shape of your lens, happens via the parasympathetic function. All right. In a nutshell, I think those were the majority. Let's see if you guys have any questions regarding anything. Do you guys have some questions for me now?
I do, Professor.
Go ahead. Sure.
So basically, I've been studying the study guide. Like, I've went over lectures as well, but I've been studying the study guide to prepare for the test. So basically, that's everything that's gonna be on the test, correct?
A study guides, as the name of it implies, is a study guide. Now, there are different interpretation of the study guide. A study guide helps you to concentrate and review the material, obviously. But if I give you a new example, which I've been doing so far, that you never heard about, and that's not on the study guide, that's something that you need to apply, okay? So a study guide might indicate that know the addition, right? So you know how to do the addition. For example, 2 plus 2 equals 4. So you know how to add. But I may not ask you 2 plus 2 equals 4. I might ask you 2 plus 6, what is it equals to? So same concept. You have to understand that I don't want to do that. I don't want to give you guys, I mean, sometimes I do, but a lot of times you might see different examples. I don't want you guys to get an impression that, oh, it wasn't in the study guide. How come you're asking us this? All right. So I don't want that to happen. You understand what I'm coming
I
from?
understand. Just understanding the concept of what's on the study guide.
Exactly. Understanding the concept, knowing your material. Okay. That is you know, my whole focus on here. And again, the overall picture is make you guys long-term learner. And that way, when you go to a different program, still the knowledge is going to be there. It sticks with you, and you can recall because you learn the material. You just didn't confine into one single thing that you could do. All right. So that's the idea. Yeah. All right. I wanted to give you guys a little bit of boost up. I don't know if you noticed this or not. I didn't cram and put in a lot of information regarding the special census for now because this exam worth 100 points. And if you guys don't study on this one, it's going to be very difficult for you guys to come back. But for those of you that were disappointed, you emailed me that you could do better and you're willing to do the work and you met with me and you either send me inbox messages or we had a private conversation or we discussed things and so on. This is the time for redemption. I have no doubt that you're going to do well if you are prepared to do so. All right. If you do not believe me, you can always check to find out if the students always getting A's in the course as well. How is it that they could do it and you can't? So again, it comes down to the preparation. Obviously, when you are stressed, you cannot, and all that. Maybe that could be the factor. And I've heard this along, and it actually happened to me. One of the things that happens, people, they have a tendency to exhaust themselves sometimes too. Right before the exam, you're trying to study all through the night and so on. And now you don't have the proper rest. Now you're tired. Now your mind is not thinking. There's less oxygen sending into the brain. And you blank out. You can't perform. Under those conditions, you're not doing the best that you could do. As far as this exam goes, I wanted you guys right now to go ahead and do exactly same thing you've done on the first exam. First exam, it was fair. It was average was around 70. We had plenty of hundreds and we had some Fs as well. I want to continue doing that. Let's see how you guys do on this one. So for this one, right now, I'm not going to request for you guys to turn your camera on to be proctored, but just go ahead and do that and see what happens. Going forward, it might be different. So if I announce it differently, then you need to be prepared. You are required to have it. But right now, this is what I like to do. The average was not extremely too high. It was right around what I expected. If it was 80% and above, then maybe I would have changed things. All right. But I don't see you guys and the type of questions that I ask. I don't see you guys really need to be proctored because I'm asking some application questions. If you do not like that, you guys can communicate with me. It doesn't mean that I'm going to change my mind, but you guys can communicate with me and I could go towards and include more of other type of questions and then have you guys have require the camera. By the way, which one do you guys like? The way it is or have a camera but more like have definition questions?
I like the way that it is.
Yeah, me too.
Me too.
Me too.
Me too.
Anybody like more straightforward questions, but have the camera? For some reason, students feel sometimes uncomfortable about their look and their settings. I don't know what it is. But
I just feel like it will add just unnecessary stress for some people.
That's what I was gonna say. I feel like I would be a lot more stressed out during the test with the camera on, not necessarily because of the way I look or anything, but just the added pressure of having the camera on you.
Exactly.
Yeah, I agree.
okay.
I don't want to be the unpopular opinion, so I don't want to say anything.
No, you guys, let me put it this way. I always like to include and get your feedback. That does not mean that I'm going to do that, because I know I'm never going to be able to make everybody happy, and I'm not here to make you guys happy. You know that, and I told you this already. All right? There's always something. I remember last semester in my anatomy class, people were asking me, please, can we have postpone the exam a week later? So I said, okay, let's make it next week. Then I get a student, I was prepared already. How come you changed the date? So I'm like, oh my God, what do I do? You know what I mean? So it's always backfires one way or the other. Okay, I wanted you guys to understand this, all right? And it can be true for you at your work or at other ways and so on. I can't even get my kids happy all the time. They want to do something and that's not appropriate, or that's not a good time, or whatever, or maybe good for my son but not good for my daughter, or vice versa. You see, it's very, very difficult. But you guys are not my children, and I have control over you just like my kids. I make a decision and I go with it. But right now I made a decision to not include the camera at this time and go from it and see. I will analyze and look at the grades and go from there, okay? But in the meantime, at one point in time, I told you this before, I will give you a survey to do, and I like to get you guys input on it and go from there, okay? I understand sometimes you feel uncomfortable. Myself, I don't like to put the camera when I give a lecture, not because the way I look great, by the way. And I always have high confidence about the way I look.
Professor?
You wanted to comment on the way I dress and so on the videos? Is that what you want to comment?
No, it's just we're like online class and we've never seen your face like this.
We're curious.
You're curious.
It was the first day.
If you go to the YouTube, now I know that you didn't watch YouTube.
Yeah, I was about
You just pass by real quick by the camera, but you don't stop so we can really admire you though.
Oh, okay. Okay.
Wink, wink.
Right now, I'm not going to reveal my identity. How about that? Because I haven't shaved. Okay?
Okay.
So I'll leave it to another day. But I'll
But
take your word for
before
it.
the last day of class,
Just
Professor,
to-
you have to show us your face.
Oh, I will. But just to give you an idea, I'm very handsome. Okay, I look good. If you had to pick between, I don't know, who's the most handsome actor right now? You guys know? Who's the most handsome guy right now?
Tom Hardy.
Who? Who are the favorite actors these days? You guys?
Hemsworth.
There's nobody on TV right now.
Nobody's on TV.
They're all old episodes.
Yeah, and then also you don't have time to watch it too, right? I know I don't. But anyways, let me put it this way. Let's just go with it the way it is, the way it was, and then if I change something, I will let you know, okay?
Professor, is there any way to make it so that, I don't know if you're going to change it for this exam, but just so that you can go back?
I can read your mind. The answer is no. All right? You cannot go back. You cannot go back. Is that what you wanted to
had
ask?
it like that for all the previous tests, and all of a sudden you changed it.
It was really hard because sometimes like I don't know right away one of the answers, and then once I do the next one, it like triggers something in my brain, and then I remember what the first one was.
Yeah, like we get it, like our brain continues to work in the background as we're reading the new question, and we're like, oh crap, it's not that. We want to go back and we can't. Like you changed it from the previous quizzes too, so it was
and also because it's
fine.
time, I feel like we have to rush and we just have to go with something, and we can't really go back to our answers and review.
Okay.
So I think it would be
okay. Let me make a comment on it. First of all, it's got to be a challenge involved, and another thing is I could change it however I want it. I wanted to do it this way now. All right. I really appreciate that you like it the other way, and I get it, but. For security reasons and also managing time situation and giving you guys not pressuring you, but understanding what you have, what amount of time you have, and to know the material rather than going back to the material and have opportunity to look things up. In other words, I do not want you guys to look things up. I need for you guys to know the material already. And I'm not going to change my mind on that one. And also, same thing with the timing.
Timing, Professor. The timing's fine. And just being able to just toggle between questions. It's okay that you want us to be on a crunch because I understand you don't want us to look anything up and everything. But just having, like, sometimes because it's a time crunch, I will leave one blank to go forward with the ones that I do know right away. And then I go back to that. And that's
my recommendation right now is I decided not to change that right now, okay? So my recommendation is this. Have a clock next to you or just look at the clock. It should be on top of your screen as well, all right? You allow 1 minute for each question. That way you have 1 minute. All the questions I ask, I go over it again with myself, and I ask myself, did I take enough time? Do I have enough time? They're all less than 1 minute availability. So, however, if you, let's say the first question is easy and you were able to do this in 20 seconds, like some of the quizzes that you take online that I gave you guys as a practice on the quizzes, you guys take like 20 seconds and so on when you prepare. So those activities, you know, if you take in 20 seconds, you don't need to read it. Just go on to the next one, and that gives you a cushion at the end. You go with what you have. I don't want you guys to go back and forth. Sorry if you're disappointed. I'm gonna go with it. Okay. Whether you like it or not. Sorry.
No, it's okay. I respect you. I just wanted to vocalize my opinion, but I respect whatever you decide.
Thank you so much for
Mostly
understanding.
it's because you
if I change it, I change it. But right now, I'm not changing it. Okay.
But you already changed it. That's the problem. In the beginning, it was fine, and then you changed it all of a sudden. Like that was where it's like, what? No, wait, I wasn't ready. I was like, cool.
Okay. At the top of the screen, there are instructions for you guys to read. It tells you what is the instructions, and the instruction clearly stated that you cannot go back and forth. So
it only happened this last quiz, though. Before that, it wouldn't come up. Like we were still able to go back to our questions until this last one that you just changed.
Yes,
the same. So you're changing it now, but it wasn't changed before. So you're changing it now, not before. It was before we were able to go back and change our answers if we wanted to. You're changing it now.
Doesn't matter. I could change it anytime I want. I could change you and give you an essay question. That does not mean why you didn't give us before. All right. Hey, I feel like I wanted to include something. So if I'm giving you something, it is something. If I'm not giving you something, I'm not giving you something. So that's up to my decision. Let's say you give a candy to your child. All right. An hour later, she comes and says, well, you gave me a candy earlier. I need another candy. I said, no, you had enough. No, but you gave it to me earlier. Give me another one. No, you had enough already, and that's my decision. Well, you gave me. Then why did you give me a candy a day before and today? I want another candy for the next day too. So I don't know if that makes sense to you, but it makes perfect sense to me.
I don't know if it would be more.
If you have it, that doesn't mean that I have to.
Professor, I don't know if it would be more work for you. I'm just throwing it out there, obviously, as you have said, and we know it's up to you. I don't know if there is a way to generate maybe both options, like an exam that has us use the camera and is more definition based, and one that is more application based without the camera, since it looks like people retain different information in different ways?
Right now, I'm going with what we have. No, it's not possible. Then it's going to open up other questions. Like I told you, some students going to communicate with the other students that took it the other way, and it's just a headache for me. And then they're going to say, "Oh, they were easy. How come you're making it hard for us?" And I don't want to do that. Okay, so these are whatever I'm doing. Believe me, it is to your benefit. If you go and ask around with the other physiology professors that I connect with, they only give out about 30 to 40 seconds per question. So be thankful with what you have. Go with it. You guys are enjoying it so far from the comments that I gotten from you. You're getting a good quality education. You're learning the material. I'm giving you guys enough work that you guys are getting engaged all the time. There are a lot of positive things that is happening. Try to focus on the positive things, okay? And, do the best you can. But, it's not for everybody. I understand that. Not everybody going to be happy. I understand that. One person might perform better on one way and other maybe perform other way. I understand that. I'm just going to go with what I have. The reason is I analyze the quizzes. I analyze the exams. They're right around the average, and I don't have any concern from my perspective. If you don't like it, you could always, mention it on the survey when I give you guys the survey, and I look to see the percentage of the people that are requesting something. And then maybe for upcoming semester, it looks like we are in the hole of COVID-19 on the fall as well, and maybe possibly next year. So if that is the case, I can include some things. A lot of things that I already include is because of the students talking to me earlier before you guys and doing the survey and giving me feedback and suggestions and so on. But I like to, handle everything on my own and hear all the voices and go with it. You already know, in anything that you look, there are always people that are not going to be happy with something. Okay, people are not happy for wearing masks. People are arguing; they don't want to wear masks. You guys know that already. But I don't want it to portray that on you or anything like that. I totally understand. You. But anyways, right now we're not going to do it on the camera. You guys going to do it on the computer. So you don't have the stress. And I'm hoping that you score a little bit higher. I'm looking at more than 70%, possibly less than 75. Usually the average is right around 70, which was the case on the first exam. But I hope that you guys do very well. And at this point in time, I want to give you guys a break and also drink some water for myself too. And you have 1 o'clock an exam, the quiz that you could take. 1:15, I'll tell you what to do. We're supposed to be looking at the chapter 17 today, folks. I took the time to go over some of the material, but you still have about an hour, 15 minutes. So if you go to the website and go to the home screen and go towards the bottom where it says exam number 3, you'll see exam number 3, and there are chapter 1. Here's the PowerPoint. Here's part 1, a link that you guys can take a look at. Here's part 2, and this is the MP4. It's the same thing. So you could look at the MP4, so that way you could download it. You don't need to record anything and so on. And that is what we are doing. And then towards, and then for the lab part, I'm just going to take the attendance, but you'll be working on lab number 10, which you have about a week to do. And that would be under the assignment, and also should be here too somewhere. If I can find it right here, hematology, introduction to the blood. All right. So, it's a good idea to get this done. If you don't, then you will have a more busy weekend because the weekend is coming up very soon. You want to focus on the exam now. That's your preference. But I'm going based on the course syllabus, folks. So if we go ahead and take a look at the course syllabus, we're having the exam number 2 tomorrow, and everything is set. We are covered chapter 17. Already posted that. We reviewed the exam for you. All right. And on the lab, we're doing the hematology. We're going fast paced, you guys. That's what it is. All right. I give you a few days so you can always utilize the weekend, knowing some of you guys are super busy with the family, with the work, with all these things. And I'm trying to give you guys enough time. If that time is not enough, communicate with me. I might be able to extend it for you if you have legitimate excuse. And if not, I might, you could always ask me for excuse, and I will see if I can give it to you maybe at the 50% reduction rate. All right, there's got to be a difference with the students that are on time. I like that. Okay, anything else you guys wanted me to cover or have question with, or
Professor?
go for it? Yes.
So the test is only 11, 13, and 14, right? Not 15?
11, 13, and 14.
Okay. Thank you.
Okay.
Will 15 be extended to exam 3, or what are we doing?
The 15, I might just give you a small quiz for it,
Okay.
just to see if you guys had the time to review it or not. But that maybe it's that happens on Monday. All right, something like that. That way you can catch up on the weekend. Okay.
Okay.
I don't want it to include that right now because, again, if I, go super fast one day, I'm not sure if that would be enough for you to retain all that information. At the weekend, the posted lecture is already there, so maybe you could just, take it as a quiz, and if you didn't do good, you could drop it. Go ahead.
Thank you, Professor. How many quizzes are there going to be total approximately for our course?
I don't have any plan. I don't have any plan of how many I will give you. Minimum, I will give you 11. Maximum, I give you whatever I can.
Okay, you said you were dropping 3 of those. Is that what it was?
I'm counting 10. If I give you 11 quiz, 1 will be dropped. If I give you 12 quiz, 2 will be dropped. If I give you 13 quiz, 3 will be dropped. If I give you 15 quiz, 5 will be dropped. Does that make sense?
It does. And you said if we had any personal issue with the timing, is that something we should mention now or inbox?
Send me an inbox message, see what happens. I know some of you guys added late. I'll try to give you an extension. And if that's the case, send it to me. I will give you the extension without any penalty. But if, it's a work schedule or something that you were not able to do, you missed the deadline because, you were not aware of it or whatever, I will deduct some points, but it still might give you the chance because I know that you wanted to work harder.
That's amazing.
Working harder is better than not working at all.
Thank you so much. Thank you.
You're welcome.
Thank you, Professor.
Okay, let me give you guys a break. I can also use a little break. Again, if you needed any question, I'll be on my computer and available. Feel free to ask. I'll be doing whatever I can to help you guys out. You do your part, I'll do my part. We'll go together and hopefully we'll be successful at it. All right. You guys take care. See you guys at afternoon for those of you that have afternoon lab. Talk to you guys later.
Thank you.
Professor?
Yes, go ahead.
I'm sorry, can I speak to you privately after, or how do I?
Sure. Send me an inbox message. I will exit, and then I could come back again because that way I don't know who's here and I don't want to keep them out right now. Okay?
Oh, okay.
Send me an inbox right now. Okay. All right.
Professor?
Yes, go ahead.
Will we be able to see what we got wrong for our quizzes?
Sure.
Okay, thank you.
Okay, send me inbox messages and I could go over it with you.
Почему все закрылось?
А потому что он вышел. Правильно?